So today we're going to be covering the question we had during Lab 8. We had a question involving regression and the ball table. So we're going to actually be just covering that right now. So we have the ball table defined, and we have 3 selected rows from the ball table given here. So we have Steph Curry with points 29 minutes 34, Klay Thompson with points 21 minutes 34, Andre Iguodala points per game 7, minutes per game 28. So from the whole table, we have calculated the following using these expressions, and then basically we have the value on the right side. So we have the NP.mean of the ball column 1. So ball column 1 refers to our points column over here. So we can actually calculate the mean of that, which gives us 13. Then we calculate the standard deviation of the same column, which gives us 8. Now we're going to try to calculate the minutes, so we actually do that here. NP.mean ball column 2 refers to the minutes column. We get the value of 24 out as the average. Then we calculate the standard deviation of ball.column 2, which then gives us 10. Now we calculate the correlation between, in the ball table of columns 1 and 2, again, points and minutes, and we get a correlation coefficient of 0.75. So now we want to ask the question, what is the value of Steph Curry's points in standard units? In order to calculate this, we need to remember our original equation. How do we convert something to standard units? So I'm going to abbreviate standard units as SU, and we can basically say that this is equal to X minus the mean of the same column that we're taking it from, or basically the set of values that we have, and we're going to divide this by the standard deviation. So in this case, X, or the point or set of points that we want to calculate on, but X is just a singular point, is going to be Steph Curry's points per game, which is 29. So now we have to find the mean of the set of points that basically correspond to the points per game. So we know for a fact that the points per game, the mean of that is going to be generated in this expressions table over here. So we're going to look that up. Column 1 refers to points, and then we take the value of 13. So we can subtract 13 from this. And then now we have to find the standard deviation, which is given by the next line down, and that's 8. So if we simplify this down, that gives us 2, because 29 minus 13 is 16, and then 16 over 8 gives us 2. So now the next question is going to ask the slope of the regression line with points per game on our y-axis and minutes per game on our x-axis, and we want to calculate the slope in original units. So based on our regression equation, we know that if we just had standard units, R is just going to be our slope for standard units if both y and x are in standard units. Unfortunately for us, this is not the case. We have to find the slope in original units, and the way we can actually do that is not that much different. We just have to add, or we just have to multiply our original R by 2 values that we have, which is actually the standard deviation of y over the standard deviation of x. So we're going to multiply r by the standard deviation of y over the standard deviation of x. So in this case, what does y and x refer to? So we can actually look this up in the original problem itself. We see that we have to have points per game on our y-axis and then minutes on our x-axis. So that means we can simplify this equation down. So this would be 0.75 as r still. Standard deviation of y, we're going to look at points, and that is going to be 8. And then we're going to look at standard deviation of x, which is going to be minutes over here, is 10. We're going to pop that into the equation. We're going to get a value of 3/4 times 4/5, which is end up going to be 3/5. Alright, so now we want to find the fitted value for Steph Curry using the regression line. So one way we can do this is that we can actually convert both the values. We can convert x over into standard units, and then we can just use r, and then from there we know what y would be in standard units, and then we convert that back over to original units. So that's the process we're going to take in this first case, and then I'm going to go ahead and do it a different way. So we're going to have the fitted value for Steph Curry, so we're going to take y equals r times x. X is going to be still our minutes, so we're going to take these minutes that we have for Steph Curry over here, and we're going to convert them over to standard units. So I'm going to say the standard unit of x is going to be equal to 34 minus, and we got to find the mean for this, 24 over 10, because 10 is the standard deviation for the minutes, and then standard units for this is just going to be 1. Now we're going to find standard units for y, which is just from the regression equation that we have, so we're going to take 0.75 times 1, which is just going to be 0.75. Now we're going to have to reverse this equation back around. So what we have here is 0.75 is going to equal our actual y value minus our mean. Our mean, again, is going to be 13, divided by the standard deviation, which is going to be 8. Now what we can do is that we can multiply 8 by 0.75. Again, that is also 3/4. So this gives us 6 equals, so this also gives us 6 equals y minus 13. So then, from extrapolating this out, we get y equals 19 as our fitted value. So we can ask ourselves a couple questions basically, and this was actually the follow-up question before we head on to evaluating the other method in order to do this. We're going to evaluate basically why y equals 19, or Steph Curry's fitted value, is so off compared to his points. Basically, if you look at how much basically Steph Curry does compared to a lot of his other teammates, obviously this table doesn't tell you the whole story, but in terms of points per minute, Steph Curry does a lot more than a lot of the other players. So by just having a value of 19, this is basically comparing himself to all of the other Warriors staff, or sorry, Warriors players. So even Klay Thompson is above this stat for minutes played, but he's also closer. So Steph Curry is just that much of an outlier in the amount of production he has per minute, and that's why this regression line seems to have this fitted value be so low in comparison to the points. Because remember how we calculated the standard units over here, this actually comes out to 2 standard units, which is pretty much equivalent to 2 standard deviations above the mean that his points are. Versus the actual prediction is going to be 0.75 standard deviations above the mean for Steph Curry based on his minutes played. So this is just a vast difference in the amount that you actually see from. If you actually compare himself to a person like Andre Iguodala, which is 7 points in 28 minutes, this starts seeming a little bit more reasonable. So now we're going to do the second method, and basically I'm going to erase this all. Now we're going to do the second method in order to cover how to find the fitted value for Steph Curry using the regression line. So we're going to use original unit values, and we're not going to convert this over to standard units. We're only going to use original units. So how we're going to do this is basically we're going to leverage what we've covered in part B in order to find out the values that would be appropriate for the situation. So if we remember, y is going to equal the slope times x plus our intercept. Since we've already calculated our slope, we just have to plug that in here. So this will be 3/5 x. And then now we have to calculate our intercept. Our intercept is calculated by taking the mean of y and subtracting that by the slope times the mean of x. So we take our mean of y, which is given to us, again, points, so we look for 13. We're going to do 24 times 3/5. That's our intercept. And now we're going to plug this back into the original equation. So y is equal to 3/5 x plus 13 minus 24 times 3/5. There's a good reason why I'm keeping it in this form for right now. Now we're actually going to plug our x value, which is our minutes, into this equation. And this equation will give us 3/5 times 34 plus 13 minus 24 times 3/5. Which again is going to, so these are basically going to equal to 10 times 3/5 plus 13, which gives us the same value as we covered before of being 19.